Good morning, students. Hope you are doing great. This is Dr. Thulasi, working as Associate Professor in the Department of Computer Science and Engineering, VNITSW Institute of Technology and Sciences for Women, Palakaluru. In the last session, we have seen the third unit. The contents of the third unit are Introduction to UML, Why we model, Conceptual model of the UML. In the conceptual model of the UML, we have seen the building blocks of the UML, rules of the UML, common mechanisms of the UML. And next we have seen the architecture. In the architecture, we have seen the 5 views of the UML. Next we have seen the classes, relationships, common mechanisms, class diagrams and object diagrams. These are the topics which we have covered in the third unit. And in today's session, we are going to discuss about the fourth unit. Coming to the contents of the fourth unit. Today we are going to study about the basic behavioral modeling. And this we are going to discuss about interactions, interaction diagrams, use cases, use case diagrams and activity diagrams. Coming to this session, coming to the next topic, use cases. A use case specifies the behavior of a subject of a system or a part of a system. It describes sequence of actions including variants that a subject performs to yield an observable result of the value to an actor. You apply use cases to capture the intended behavior of the system you are developing without having to specify how the behavior is implemented. Use cases provide a way for your developers to come to a common understanding with your systems and users and domain experts. In addition, use cases serve to help validate your architecture and to verify your system as it evolves during the development. As you implement your system, these use cases are realized by collaboration whose elements work together to carry out each use case. Well-structured use cases denote essential subject behaviors only and are neither overly general nor too specific. If you see the figure here we are having 2 figures. One represents the actor, that is a sticky figure, and second one is the ellipse that represents the use case. So in the use case, you can write the name of the use case, and for the actor, you can specify the role of that particular actor. So a use case is a description of a set of sequence of actions, including variants that a system performs to yield an observable result of value to an actor. Graphically, a use case is rendered as an ellipse. Coming to the subject. Subject is nothing but the, if you see the figure, you can, next I'll show you the figure. In that you will consider a system that is represented in a block box. That is nothing but the subject. The subject is a class described by a set of use cases. Usually the class is a system or subsystem. The use cases represent aspects of the behavior of the class. The actors represent aspects of other classes that interact with the subject. Taken together, the use cases describe the complete behavior of the subject. You can see in the figure how the subject is represented. Coming to the names. So, every use case must have a name that distinguishes it from other use cases. A name is a textual string. That name alone is known as a simple name. A qualified name is the use case name prefixed by the name of the package in which the use case lives. A use case is typically drawn showing only its name. If you see the figures here, we are having some simple names and qualified name. Simple name means placing order, validating user. These are the simple use cases. Coming to the qualified name, in the classes we already know that if the classes are conceptually connected, then we place all these classes in a package and we'll give that package name and the class name. Here also similarly, the conceptually similar use cases are placed in a package. If you see here, sensors calibrate location. It means sensor is a package, calibrate location. If you go in a car and your GPS will be calibrating the location. So that is one type of a sensor. So it is placed in the sensors package. So this is known as a qualified name. Always see here, use case means it always tells about the sequence of actions. If you want to place an order, what are the sequence of actions? First of all, you need to register for the website. Next, you need to log in. Next, you need to select an item. You need to place in the cart. You need to do the transaction. After the completion of the transaction successful, you can place the order. So these are the set of the actions for a single use case. So even validating user also. So user first should be registered for a particular website. Later he'll have his own credentials of a login and password. Later he'll give his login and password and he'll enter the website. That login ID and password will be verified, and then only he'll be considered as a validate user. So these are the set of the actions done before validating a user. So always the use case tells about the sequence of actions taken place. And coming to the use cases and actors. An actor represents a coherent set of roles that users of use cases play when interacting with these use cases. Typically, an actor represents a role that a human, a hardware device, or even another system plays with a system. So, actor is a sticky figure. He represents the roles placed in a particular system. So, if you consider a banking example, so if you work for a bank, you might be a loan officer. You do your personal banking there as well. You will also play the role as a customer. So sometimes single actor may play multiple roles also. An instance of an actor therefore represents an individual interaction with the system in a specific way. Although you will use actors in your models, actors are not actually part of the software application. They live outside the application within the surrounding environment. Sometimes they are not the software. Actors might be some humans, non-humans, passive, active, primary, secondary. Okay, these are all types of the actors. So they are not a part of the software. They live outside the subject. They live outside the block box. So I already shown you the figure. That is that represents the actors. So in an executing system, actors need not exist as a separate entities. One object may play the part of the multiple actors. For example, one person may be both a loan officer and a customer. An actor represents one aspect of the object. Actors are rendered as a sticky figures. As I told you that actors are graphically represented as a sticky figures. You can define general kinds of actors and specialize them using a generalization relationship. Sometimes, if you consider one of the customer, and the commercial customer is one of the type in it. So you know that if the child class acquiring the properties from the parent class, you can use a generalization relationship. So here customer is a generalized class, and coming to the commercial customer is a specialized class. To represent the relationship between them, you can use a generalization. So actors may be connected to use cases only by association. This is one of the important point. An association between an actor and use case indicates that an actor and the use case communicate with one another, each possibly sending and receiving messages. Okay, if we have seen that if there are four types of relationships, first one is a dependency, association, generalization, realization. Coming to the dependency, that is a using kind of relationship. Only one object will be using the information or operations of the another object. Coming to the association, it can both they can send and receive the messages. If you use the generalization, it is like a parent and child relationship. If you consider the realization, here it is between two classifiers. One classifier specifies the operations and another classifier tries to carry out those operations. Then you can represent by using a realization. Here you need to use the association because the use cases and actors send and receive the messages. Coming to the use cases and flow of events. A use case describes what a system does, but it does not specify how it does. When you model, it is important that you keep clear the separation of concerns between this outside and inside view. You can specify the behavior of a use case by describing flow of events in text clearly enough for an outsider to understand it easily. When you write this flow of events, you should include how and when the use case starts and ends, when the use case interacts with the actors and what objects are exchanged, and the basic flow and alternative flows of the behavior. For example, in the context of an ATM system, you might describe the use case validate user in the following ways. Main flow of events. So the use case starts when the system prompts a customer for a PIN number. The customer can now enter the PIN number via the keypad. The customer commits the entry by pressing the enter button. The system then checks the PIN number to see if it is valid. If the PIN number is valid, the system acknowledges the entry, thus ending the use case. Exceptional follows. So these are different from the direct flow. So the customer can cancel the transaction at any time by pressing the cancel button, thus restarting the use case. No changes are made to the customer's account. Next, one more exceptional case also will be there. That is, the customer can clear a PIN number anytime before committing it and re-enter a new PIN number. This also won't affect the account of the customer. Next one is if the customer enters an invalid PIN number, the use case restarts. If this happens 3 times in a row, the system cancels the entire transaction, prevents the customer from interacting with the ATM for 60 seconds. These are the different ways how you can create the flow of events. Coming to the one of the important point we need to discuss in the use cases is you can specify a use cases flow of events in a number of ways, including informal structured text, formal structured text with preconditions, post-conditions, state machines, activity diagrams, and pseudocode also. Next one is coming to the use cases and scenarios. Typically, you will first describe the flow of events for a use case in text. As you refine your understanding of your system's requirements, however, you will want to also use interaction diagrams to specify these flows graphically. Typically, you will use one sequence diagram to specify a use case's main flow and the variations of the diagrams to specify the use case's exceptional flows. It is desirable to separate main versus alternative flows because a use case describes a set of sequences, not just a single sequence. And it should be impossible to express all the details of an interesting use case in just one sequence. So you go for the alternative ways also. For example, in a human resources system, you might find the use case hire employee. So I'm going to tell about an example. Human resources system, you need to hire an employee. This general business function might have multiple possible variations. You might hire a person from another company, and this might be one scenario. You might transfer a person from one division to another. This is also common in international companies. Or you might hire a foreign national, which involves in its own special rules. Each of these variants can be expressed in different sequences. This one use case, hire employee, actually describes a set of sequences in which each sequence in the set represents one possible flow through all these variations. Each sequence is called a scenario. It means if you transfer from one branch to another branch, that is also one hiring. If you transfer from international also, that also one hiring. So from an outside company also you can hire. These are nothing but the different scenarios. A scenario is a specific sequence of actions that illustrates behavior. Scenarios are to use cases as instances are to classes, meaning that scenario is basically one instance of the use case. If you consider a use case, then I told you that use case is a set of sequences and one sequence is nothing but a one scenario. And all these scenarios comes under these are the instances of the use cases. And one of the important point I would like to tell here is there is an expansion factor from use cases to scenarios. A modestly complex system might have a few dozen use cases that captures its behavior. And each use case might expand out to several dozen scenarios. For each use case, you will find primarily scenarios and secondary scenarios. Might be the secondary scenarios are nothing but the alternative sequences. Coming to the next one, use cases and collaboration. A use case captures the intended behavior of the system you are developing without having to specify how the behavior is implemented. There's an important separation between the analysis of a system should, as much as possible, not to be influenced by the implementation issues. Ultimately, however, you have to implement your use cases and you do so by creating a society of classes and other elements that work together to implement the behavior of the use case. I told you that collaboration is nothing but a collaborating, combining all the elements to work together. So here use cases are used in collaborations and this society of elements including both static and dynamic structures also and modeled in the UML as a collaboration. Okay, if you see the figure here, you can explicitly specify the realization of a use case by a collaboration. See here, we are having a placing an order, that is nothing but a use case. And order management, it is consists of a set of roles and that is given as a relationship as a realization. So this is how the collaboration is combined with the use case. Most of the time, through a given use case is realized by exactly one collaboration. So you will not need to model this relationship explicitly. Okay, this is regarding the use case and collaborations. Next, coming to the organizing use cases. How you need to arrange the use cases. You can arrange use cases by grouping them in a package in the same manner in which you can organize classes also. So, which are conceptually equivalent, you can group them in a package. You can also organize use cases by specifying generalization, include and extend relationships among them. You can apply these relationships in order to factor common behavior. It means, and in order to factor variance also. So here we know that generalization among use cases is just like a generalization among the classes. So where we have used this generalization means if the subclass acquiring the properties from the parent class, then you go for the generalization. Here the child use case inherits the behavior and meaning of the parent use case. The child may add to or override the behavior of its parent, and the child may be substituted any place the parent appears. So, for example, in a banking system, you might have the use case validate user, which is responsible for verifying the identity of the user. You might then have two specialized children of this use case. First might be through check password you can enter the system, or else you can use the retinal scan also you can enter the system. Both of which behaves you like a validate user only and may be applied anywhere. Validate user appears. Okay, for validating the user you can use the by password or you can use the retinal. Both can be applied, and yet both of which add their own behavior. So as shown in the figure. So if you see the figure, a generalization among use cases is rendered as a solid directed line with a large rectangle arrowhead, just like a generalization among the classes. If you see the figure here, it also represents not only the generalization but it also representing the include and extend also. So if you see the figure here, so it is a validate user. Here we are using two methods to validate the user. First one is a check password and a retinal. Anyone can be used. So these are the subclasses for the parent class validate user. Next we are having a after validating the user, what are included. If you validate him as a legitimate user, he can track the order, he can place the order, whatever want, he can do it. That is included in the login. By entering the, if he is a validate customer, he can do all these things. What is extend? Extend is something different, which is a apart from this, we can add some extra features. If you want some extra features, then you can go for the extend. So what does it means? So as a normal customer, you can place the order, that is included. So if you are an Amazon Prime customer, you can have some more benefits in the similar way. So placing a order is common for all the customers. If you are some special, then you can place a rush order. That is the extend. So see here, an include relationship between use cases means that the base use case explicitly incorporates the behavior of another use case at a location specified in the base. The included use case never stands alone, but it is only instantiated as a part of some larger base that includes it. You can think of include as a base use case pulling the behavior from the supplier use case. You use an include relationship to avoid describing the same flow of events several times by putting the common behavior in a use case of its own. And the include relationship is essentially an example of delegation. You take a set of responsibilities of the system and capture it in one place. Then let all other parts of the system include the new aggregation of responsibilities whenever they need to use the functionality. You render an include relationship as a dependency stereotyped as a include to specify the location in a flow of events in which the base use case includes the behavior of another. You simply write the include followed by the name of the use case you want to include. Next, coming to the important note, there is no predefined UML notation for expressing use case scenarios. The syntax used here is a kind of a structured natural language. Coming to the next one. An extend relationship between the use cases means that the base use case implicitly incorporates the behavior of another use case at a location specified indirectly by extending the use case. The base use case may stand alone, but under certain conditions its behavior may be extended by the behavior of another use case. This base use case may be extended only at certain points called, not surprisingly, it's the extension points. You can think of the extend as the extension use case pushing behavior to the base use case. So we have seen here placing the order. After placing the place the rush order. So it means if you want to get the order very fastly, then you can rush order. So you use an extend relationship to model the part of the use case the user may see as optional system behavior. It is not mandatory to have the extended relationship, but it is an optional part. In this way, you separate optional behavior from the mandatory behavior. You may also use an extend relationship to model a separate subflow that is executed only under given conditions. Finally, you may use an extend relationship to model several flows that may be inserted at certain point governed by explicit interaction with an actor. You may also use an extend relationship to distinguish configurable parts of the implementable system. The implication is that system can exist with or without the various extensions. You render an extends relationship as a dependency stereotyped as extend. You may list the extension points of the base use case in an extra compartment. If you see in the above figure, here we are having in the placing order, we are having some compartment. So in that we are having extension point. From there we have extended the rush hour, place a rush hour. Okay, this is how you can use the extend. Okay, next coming to the important point. So organizing your use cases by extracting common behavior and distinguishing variants is an important part of creating a simple, balanced and understandable set of use cases of your system. Coming to the other features, use cases are classifiers. So they may have attributes and operations that you may render just as the classes. You can think of these attributes as the objects inside the use cases that you need to describe its outside behavior. Similarly, you can think of these operations as the actions of the system. You need to describe a flow of events. These objects and operations may be useful in your interaction diagram to specify the behavior of the use case. As a classifier, you can also attach state machines to use cases. You can use state machines as another way to describe the behavior represented by a use case. Coming to the common modeling techniques of the use case. We are having only one common modeling technique, that is to model the behavior of an element. The most common thing for which you will apply use case is to model the behavior of an element, whether it is a system or a whole or a subsystem or a class. When you model the behavior of these things, it is important that you focus on what the element does, not how it does. Applying use cases to the elements in the way is important for three reasons. First, by modeling the behavior of the element with use cases, you provide a way for domain experts to specify its outside view to a degree sufficient for the developer to construct its inside view. Use cases provide a forum for your domain experts and users and developers to communicate with one another. Second, use case provides a way for the developers to approach an element and understand it. A system, subsystem or a class may be complex and full of operators and other parts. By specifying an element's use case, you help users of these elements to approach them in a direct way, according to how they are likely to use them. In the absence of such use cases, users have to discover on their own how to use those elements. Use cases let the author of an element communicate his or her intent about how the element should be used. Third, use cases serve as the basis for developing tests for each element as it evolves during the development. By deriving tests from the use cases and applying them repeatedly, you continuously validate the implementation. This is regarding the use cases. And coming to the how to model the behavior of an element. First of all, you need to identify the actors that interact with the element. And candidate actors include groups that require certain behavior to perform their task, or they need directly or indirectly to perform the element's function. Next, coming to the organize actors by identifying general and more specialized. If there are general and more specialized, then you represent by using a generalization relationship. For each actor, consider the primary ways in which that actor interacts with the element. Consider also the interaction that changes the state of the element or its environment, or that evolve a response to some event. Consider also the exceptional ways in which each actor interacts with the element. Organize these behaviors as use cases, applying include, extend, and generalization to factor common behavior and distinguish exceptional behavior. So if you consider the example here, we are having some customers, validate customer, and we are having placing order, track order, ship partial order, bill customer. These are some of the use cases in a retail system. So what are included means if you validate the customer, automatically you can place the order, you can track the order, you can ship order. So what is the extraordinary feature here is by using extend. Here it is having another compartment. By using that extension point, it can get the shipment partial order also it can give. It means partial order means to some location it can place some orders. To another location it can place some other orders. This is the extraordinary feature. So if you want to show some additional features, additional benefits, you can go for the extend. As your model gets bigger, you will find the many use cases tend to cluster together in groups that are conceptually and semantically related. In the UML, you can use package to model these cluster of use cases. Coming to the few hints and tips. When you model the use cases in the UML, every use case should represent some distinct and identifiable behavior of the system or part of the system. A well-structured use case names a single identifiable and reasonable atomic behavior of the system or part of the system. Factors common behavior by pulling such behavior from other use cases that it includes. So describes the flow of events clearly enough for an outsider to easily understand, and it is described by a minimal set of scenarios and specify the normal and variant semantics of the use case. So this is regarding the use case. So we have seen that a use case is represents a sequence of actions, and we have seen about the relationships in the use cases like generalization, extend, and include. And the use case common modeling technique is it is used to represent the behavior of the element. This is regarding the use cases. Next, coming to recap. Let's have a quick recap about the topics which we have discussed so far. In this unit 4, we have discussed about the basic behavioral diagrams, in which we have discussed about the interactions. In the interactions, we have seen about what is an interaction, what are the messages and the links, and how to use the stereotypes while using the links. And we have seen about the sequence diagram. In the sequence diagram, we have discussed about the lifeline and focus of the control. Coming to the collaboration diagram, we have discussed about the links and the sequence number. We came to know that sequence diagram and collaboration diagram are semantically equivalent and isomorphic. And we have seen the common modeling techniques of interactions. In the interactions, we have seen only one common modeling technique, that is to model the flow of control. Next, coming to the interaction diagrams. In the interaction diagrams, we have gone in detail about the sequence diagrams and the collaboration diagrams. Both are semantically equivalent and both are isomorphic, but they are not representing the same information. Okay, coming to the common modeling techniques of interaction diagrams, we have seen two common modeling techniques to model the flow of control by time ordering, and second one is to model the flow of control by organization. So these are the two common modeling techniques we have discussed in the interaction diagrams. Next, we have seen about the use cases, and we came to know that use cases are used to represent the scenarios or set of these sequences. And next, in the coming to the common modeling techniques of the use cases, these are used to represent the behavior of the elements. And next, we have seen about the use case diagrams. In the use case diagrams, we have discussed about the relationships such as generalization, extend, and include. And coming to the common modeling techniques of use case diagrams, we have discussed about the modeling the requirements of a system, and next is modeling the context of a system. And coming to the last interaction diagram which we have discussed in this basic behavioral modeling is activity diagram. So here we have seen about what is an activity, what are the activity states, and we have seen about the swim lanes, and these are the different topics which are new to us. We have discussed all these things. And coming to the common modeling techniques of activity diagrams, we have discussed about how to model the time constraint and how to model the distribution of objects. That's what we have seen in this basic behavioral modeling. And this is regarding a quick recap regarding the unit 4. Next, coming to the important topic, that is interesting one also, that is quiz. And by seeing this quiz questions, you will understand how you are clear about the topics. So let me start the quiz. First question. Dash are used to model the dynamic aspects of collaboration. Coming to the options, sequence diagram, structural, interactions, D messages. So the answer is interactions. Coming to the second question, interaction diagrams are of dash types. So options are 1, 2, 3 and 4. So interaction diagrams exist in two forms. One is the sequence diagram, second one is the collaboration. Dash diagrams permit you to model the lifetime of an object. So if you want to tell about the lifetime of an object, which diagram is used? So sequence diagram, collaboration, state chart, activity. So we know that lifetime can be represented by using the lifeline of an object. That can be represented in the sequence diagram. And dash shows an interaction consists of a set of objects and their relationships including messages. So options are interaction, class, use case, activity. So it is telling about the interaction, objects and their relationships. That is none other than interaction diagrams. Next question. The behavior of a system is modeled using class diagram, activity diagram, use case diagram, interaction diagram. This can be done by using the use case diagram. That's what we have seen in the while telling about the architecture of the UML also. We have seen about the 5 views. In that one of the view is use case view. In that it tells about the behavior of the system. In an activity diagram, organizing the activities into groups is called options forking, joining, swim lanes, synchronization. Option C, swim lane. Dash is used to represent concurrent flows in an activity diagram. The options are slide bar, synchronization bar, swim lane, branch. The answer is synchronization bar. Coming to the next question. Executable atomic computations are called A. Action states, activity states, composite states, concurrent states. The answer is action states. Activity diagram is a special kind of dash. Use case diagram, state chart diagram, interaction diagram, component diagram. The answer is state chart diagram. Which of the following diagram view the whole system as a block box? So, class diagram, activity diagram, use case diagram, interaction diagram. So, block box, that is nothing but use case diagram. Actors are connected to the use cases only by association relationship, generalization, realization, dependency. We have already discussed this, that is association. Forward engineering is the process of translating dash. Options model to model, code to model, model to code, code to code. That is model to code. Dash relationship between use cases means the base use case explicitly incorporates the behavior of another use case at a location specified in the base. The options are exclude, extend, include, abstract. The answer is include. So these are the few questions which we have covered in the basic behavioral modeling, and if you can answer these questions, you understood the class well. If you have any doubts, go back and play the video. Okay, if you think that I am going a little bit fast, then play the video slowly. Hope you people know about it. If you don't have any idea, just go to the settings symbol on the video, click on playback speed, then customize the speed according to your need. Thank you so much. Let's meet in the next session with the Unit 5. Till then, have a safe day. Follow SMS. SMS means sanitizers, masks and social distancing. Stay safe, stay healthy. Thank you.